All right. Good morning, everyone. So morning pa pala. Wala pang 12 noon. Okay. Good morning, and today we'll start a brand new chapter in Math 174. But before that, a quick reminder. So bukas yung start ng first problem set natin. So it will be live on Canvas at 8 a.m. And then tama nga ba, deadline natin ay November 1, right before midnight. So I'll give you four problems. Hindi ko pa siya tapos isulat, but I'll make it four problems because I know that you guys might also have other problem sets to worry about. Kasi baka pare-parehas kami ng naisip ng mga instructors nyo na tapusin lang ang problem sets before the start of the reading break. So yeah, four problems. So hopefully you'll find enough time to do them all. But again, please take a look again at your programs. Baka kasi gamitin niyo siya. I plan to give you uh, at least one problem, probably one or two that will require you to use one of the programs that you used before. Or pwedeng program siya dun sa isa nating topic na hindi natanong dun sa lab exercises. So I'll review the lab exercises probably later today and see ano yung kulang, tapos yun yung ipapagawa ko sa problem set. Then some of them might be conceptual in nature. So yeah, paghaluhaluin natin na sa problem set. Okay. Now, so today we'll start with module 6, which starts numerical differentiation, the second chapter in Math 174. And so in-adjust ko yung timing ng module 6. So module 6 is scheduled uh, for this week, 25th to 29th of October. Iba na to dun sa present ko dun sa course guide. Pero dahil medyo mabagal tayo sa lecture, kaya kailangan natin mag-adjust. Though I still made a typo in the uploaded version of module 6. Nilagay ko November 8 yung lab session nyo para sa module na to. Pero yun nga pala ay reading break pa rin yung November 8. So that's why the lab session for this module, and I think also module 7 would be both on November 15th. Tapos dun din yung deadline ng lab exer 4. So isa lang yung exer natin for module 6 and 7. And I think the earliest that we can have it is on November 15th. Okay. Now for this module, our goals are the following. Number one, derive a finite difference formula for numerical differentiation of a certain order. Second is to determine an upper bound for the error incurred in numerical differentiation. So kung napapansin nyo, laging ganito yung template natin. Mag-derive tayo ng isang formula para sa isang method to answer a certain mathematical problem, right? Or something that arises from, or a problem that arises from consideration of applied problems or real world data. Tapos hindi natin magamit yung mga techniques natin sa math 36, 37, or 38. Kaya kailangan natin mag-devise ng isang way para maipilit na magamit natin yung mga methods na yon. Tapos hindi lang natin titingnan kung ano yung mga existing methods, diniderive natin yung mga formulas o yung mga methods na to give us an understanding para pag kayo na yung nagtitesis or nag-ESP, tapos hindi applicable yung mga methods na natutunan nyo sa 174. So ibig sabihin, kaya nyo mag-derive ng a little or a slightly different method that might be more applicable to your particular problem. Okay. And then we don't stop at developing a formula or a method. We also look at the upper bounds for the errors. So titingnan natin how accurate the method is and how fast the convergence to the true answer would be. Okay, and that's part number 2. And of course, the objective number 3 is our mainstay. We want to use numerical differentiation to solve scientific problems. Okay, so let's start. So isa ring problema sa numerical kung bakit titingnan natin yung numerical differentiation, katulad din nun sa una, sa approximation at saka sa interpolation. Usually, nakukuha nating data from real world are discrete in nature, right? So kung nagpe-perform ka ng experiment, you do measurements, you get a finite set of measurements, and that would be a discrete set, right? At kung discrete set yung data mo, hindi mo magagamit yung definition ng derivative mula sa Math 36 kasi kailangan mo ng isang function para ma-define yung derivative. You'll go to the concept of limits, of of the divided differences as the increment approaches 0 and so on. But again, that will require a continuous or that will require a function. But for us, that might not be present in real life scenarios. Kaya titingnan natin ano yung pwede nating gawing solusyon kapag wala tayong function na given, pero yet kailangan natin yung derivative. And to illustrate it, halimbawa, gusto kong tingnan yung proportionality constant between or halimbawa gusto kong kunin yung coefficient of friction. The coefficient of friction mu is defined to be the proportionality constant between the rate of change of force and the magnitude of the force. So ito yung definition ng coefficient of friction. Tapos pag gusto natin siyang ma-compute experimentally, of course, wala akong function capital F. So wala akong function capital F kasi ang pwede ko lang makuha or ma-observe ay discrete set of data. So I don't have any means on how to compute capital F prime exactly. And kahit nga si capital F, hindi natin alam kasi hindi given yung function in terms of the usual form we know in Math 36. But instead, we can calculate or we can approximate the coefficient of friction by doing an experiment, right? So suppose we want to obtain the coefficient of friction mu by measuring the force F. So see F yung force that is required to overcome a 5-pound restraining force in varying angles. So gagawa tayo ng experiment. Maglalagay ako ng isang 5-pound object, tapos papaikutin ko siya sa isang post, tapos gagamitin ko yung angle. I'll use different angles theta, and then I'll perform some measurements. Tapos kunwari, ang measure natin na required force ay yung given dito sa table 6.1. So that means whenever the angle between the post and the mast that we suspended to that post ay 0 degrees, kailangan natin ng 5 newtons of force. Now, if the angle now is pi over 2, we'll need 7.83 newtons. Kung 3 pi over, kung pi yung angle, we'll need 12.27 newtons, and so on. So, nakuha natin yung discrete set of data. Tapos sabi nga natin si mu, yung coefficient of friction, siya yung proportionality constant between the derivative of the force over the force. Right? Kaya lang ang problema dito, hindi natin alam kung ano si capital big F. Instead of an explicit form for big F, we have some values of big F for certain values of theta. Ito lang yung nakuha natin sa real world data. So how can we get or how can we approximate the coefficient of friction using only this data? Wala akong F prime. But do you guys have a hula or a guess or an idea? Ano kaya yung pwede natin gawin para ma-compute si mu? Knowing that mu has this formula. Any volunteers? Ano kaya yung pwede natin gawin? We already encountered this before. So how do you think we can go about it using the knowledge that we gained from chapter 1 or from unit 1? Ang kailangan ko ay si capital F. Yes, Ezekiel, nakita ko nag-unmute ka for a moment.
Pwede po tayong mag-interpolate ng polynomial. Tapos yung polynomial na gagamitin natin is i-differentiate po natin para makuha yung f prime.
Okay, great. That's right, Ezekiel. So, ito yung common nating ginagawa, right? Ito yung natutunan natin before. Pag meron kang discrete set of data, kaya nating bumuo ng function. And Ezekiel is right. Pwedeng gumamit ako ng interpolating polynomial para kay capital F. I'll get an interpolating polynomial, say capital P. Siya yung i-differentiate ko, siya yung i-divide ko kay P, and voila, we'll get an approximate for mu, right? I guess I wrote that here. Nasa equation 6.2, nakuha natin yung interpolating polynomial para kay capital F. So instead of computing mu as the ratio between the derivative of f and f, between the derivative of f and f, kunin natin yung p prime over p where p is the algebraic interpolating polynomial. So ito yung nakuha nating algebraic interpolating polynomial. Ito yung derivative niya. Then, makukuha natin yung approximate natin sa coefficient of friction. and let's call it mu of theta. So it's going to be p prime over p. Tapos pag ginraph natin yung mu prime, defined at 6.4, obtained as the ratio of the algebraic interpolating polynomial's derivative and itself. Ito yung makukuha natin. Okay. So yung nasa figure 6.1. And you will see that aside from the, or except for numbers near the left end of the interpolatory interval, mukhang nag-stabilize yung value nung ni mu prime or ni mu tilde around 0.286. Tapos si mu kasi constant. Sabi natin si mu ay yung coefficient of friction, siya yung constant of proportionality. So you can say that approximately, whenever theta is from pi over 2 until 5 pi, the value of the coefficient of friction is around 0.286. So that's one way on how to go about the problem of deriving a derivative formula para sa isang function, right? Kunin mo yung first derivative, kunin mo yung interpolating polynomial, i-differentiate mo siya. That will give us an approximate. However, be careful about that. Kung gagamitin nyo yung algebraic interpolating polynomial, may inherit nung derivative niya yung domain ng AIP. Remember, we only use the algebraic interpolating polynomial or any interpolating function for that matter for x's between the smallest and the largest abscissa. So ang domain ng mga interpolating functions natin ay simula sa pinakamaliit na x hanggang sa pinakamalaking x value na ginamit natin dun sa interpolatory process, right? So ganun din yung derivative. So hindi siya valid sa labas ng interpolatory interval. Okay? Now again, there are some disadvantages to it. So kung si P ay malaking polynomial, so posible na magkaroon siya ng wiggles, right? Or oscillation. I mean, the Runge phenomenon can occur. So ibig sabihin, baka ganun din yung mangyari kay P prime. And we don't want that to happen. And another problem is that the more data points you use, the more prone the process to the Runge phenomenon and also to instability. Parang na-inherit ng procedure na to lahat ng disadvantages ng interpolation. Okay? Kaya usually hindi natin ginagamit yung AIP to approximate the derivative. But for some cases, it might be useful for some applications, lalo na kung hindi naman siya affected by the Runge phenomenon. Okay? So we'll not focus much on this because that will just be a corollary of what we learned from chapter 1. So instead, we'll introduce one more method, isang alternative method, which is the one that is usually used in applications, and that would be approximating derivatives using finite differences. Okay. Now, in-illustrate siya dito. Actually, ang inuna dito ay gumamit lang ng 2 points, pero algebraic interpolating polynomial rin yung ginamit. Tapos papakita natin na there is a corresponding formula for this using finite differences. Okay? So halimbawa, meron kang function f, tapos susundin natin yung suggestion ni Ezekiel na gumamit ng interpolating polynomial. Kunwari, 2 points lang muna, x0 and x1. Okay? So ang nangyari dun sa general example kanina, malaki yung degree. Pero pag pinaliit natin yung degree, gumamit lang tayo ng 2 points. So yung interpolatory polynomial for the function f, or the interpolating polynomial for the function capital F will be linear, right? Kung 2 points lang yung gagamitin ko na si x0 at saka si x1. And then if you will use the Lagrange form, ito yung makukuha yung formula para sa algebraic interpolating polynomial. So ito yung first, ito yung second, and then itong third term will just be the error term. Ito yung product ng second derivative evaluated at 1 plus 1 factorial, so 2 factorial times omega, right? So sinulat ko lang siya explicitly, kaya equal sign yung nandyan. Right? So ibig sabihin, ito yung eksaktong function f written in terms of the Lagrange polynomial of degree 1 plus the error term. Tapos ito yung ginawa natin kanina. So kung wala kang function, i-interpolate mo siya, tapos yun yung kuna mo ng derivative to get an approximation to the derivative of the actual function that you are approximating. So kunin ko yung derivative with respect to x. So ito lang naman ay linear. So kunin nyo lang lahat ng linear factors. So yung f of x sub 0 times x minus x1, sila ay constants. So lalabas sila dun sa derivative. Tapos yung derivative ng x minus x1 is a constant. So ang derivative niya lang ay 1. So ito yung derivative ng first term, derivative ng second term, medyo tricky yung derivative ng third term o ng error term kasi ito ay isang quadratic function. So kailangan ko ditong mag-product rule, right? So I'm gonna copy, so kung i-treat ko to as my first factor, so first factor, ito, times derivative nung pangalawa. Or tama ba yung pagkaka-differentiate ko? So kindly double check, let's see, bakit ganito yung pagkaka-differentiate ko? Bakit kinopya ko ito? Di ba ang product rule like copy one of the factors then differentiate the second? I think nag-ano dito. Sinulat siya in this manner. Pero pag sinimplify nyo to, ito yung magiging equal siya dun sa makukuha natin if we use the product rule. Right, so bakit ko nga ba siya sinulat in this particular form? Tingnan ko kung may apparent reason. Sinulat ko siya ng ganito para mas madali siya pag in-evaluate when x is equal to x sub 0. Okay? Kasi gusto nating makita ano yung approximate derivative when x is equal to x sub 0. When you plug in x equals x sub 0 into this formula, we'll get this. So ito yung approximate natin para sa derivative kay x sub 0. And you see that the formula for the derivative at x sub 0 only depends on two things. The function depends on four things. The function value at x1, function value at x0, x1, and x sub 0. So ang approximate natin sa derivative ni x sub 0 ay f of x minus f of x sub 0 over x1 minus x sub 0 plus the error term. Okay? Hindi pala ito approximate. Ito na yung eksakto kasi dinagdag ko yung error term. If you want to get the approximates, then you can say f prime of x, f prime at x sub 0 is approximately equal to this guy. All right? Period. So kung gusto nyo equality, dagdag nyo yung error term. But the problem here is we cannot compute the error exactly because we don't know what c is. Ang alam lang natin si c ay isang number between x sub 0 and x sub 1. Okay? Na-inherit niya yung property mula sa interpolatory polynomial. Okay? And then you see here that medyo familiar itong approximate para sa derivative. Do you guys remember what this quotient represents? Anyone? And probably you can also comment, bakit kaya nagbe-make sense na siya yung derivative, siya yung approximate para sa derivative? Yes, Chazel. Nakita ko nag-unmute ka for a split second there.
Sir, slope po ba?
Okay, yeah, correct. That would be the slope. Siya yung slope ng line passing through x0 and x1. And remember, ang slope, ang definition lang naman ng derivative ay slope ng tangent line. Itong nakabox dito sa formula na to ay slope ng secant line, right? Slope ng line passing through different points. And whenever x1 and x2 are close to each other, then this slope is a good approximation to the slope of the tangent line, right? So halimbawa, ito yung graph ng function. Ito yung graph ng function f natin. Yung derivative at this point, ito si x sub 0. Okay? Ang derivative dyan, yung slope ng tangent line. So siya yung slope nitong yellow line na ito, right? Pero kapag kumuha ka ng secant line, Kasi ang sabi yung pang-approximate natin according to that formula is the slope of a secant line passing through x0 and the point when x is equal to x1. Halimbawa to si x1. Okay? So ang nako-compute natin mula dun sa approximate formula ay ito. Or something like that, yung slope ng orange line dito. And you see that when x sub 1 is chosen to be very, very close to x sub 0, then we will get very, very close to the slope of the tangent line. Okay? Kaya medyo nagme-make sense yung formula. So kung 2 points lang pala yung gagamitin mo, yung slope ng tangent line ay ma-approximate mo ng slope ng secant line. And the approximation becomes better and better as the second point becomes very, very close to x sub 0. Okay? Kaya from a mathematical point of view, this approximation makes sense. And this is nice because the error term here, and that will be justified further by looking at the error term. Ito yung nagsasabi ng error, right? What will happen when x sub 0 becomes very, very close to x sub 1? Kapag ka si x sub 0 ay malapit na malapit kay x sub 1, this difference becomes closer and closer to 0. Kung closer to ng closer kay 0, this term will become closer and closer to 0. Therefore, the error term becomes closer and closer to 0. So, ibig sabihin, paganda ng paganda talaga yung approximation natin. Okay? Now, you can extend this derivation by increasing the number of points used. Tapos, kaya lang medyo magiging, magiging messy na yung calculations kasi dumarami na yung terms. Tapos, bawat isang term dun sa Lagrange interpolating polynomial will be a polynomial of high degree. So, pwede mo silang i-simplify, kaya lang matrabaho. Imagine, kung bawat term dito ay degree, say 10, right? So, ibig sabihin, mag-multiply ka ng 10 binomials o kaya magpa-product rule ka 10 times, which is not fun to do, right? So, yun yung mga pitfall or mga difficulties by using the algebraic interpolating polynomial solely to get an approximation for the derivative. And hence, we will introduce another method, as I've mentioned before, gagamitin natin ay approximation by finite differences, wherein mas kukonte yung ipapagawa natin sa computers because almost all the calculations will be done by hand. Tapos kung makikita nyo, yung mga resulting formula can be easily computed via computers. So wala masyadong instability na mangyayari due to machine calculations or due to machine epsilon. Okay? Now, approximation by finite differences is hinged on this classic result by Taylor. So ito, kung matatandaan niyo yung Taylor's theorem from math, saan niyo ba ito na-encounter? Math 38, when you talk about series or Taylor series expansion. So if you consider a function f that is defined in some neighborhood capital X of a number little x, and that function little f has continuous derivatives of all orders, then pwede nating i-expand si f of x plus h to be this summation, okay, this infinite series, and then spelled out ito siya. So we can write f of x plus h as a linear combination, or actually hindi pala linear combination, pero an infinite linear combination of the derivative of the function values weighted against powers of h. So tandaan nyo lang to, itong equation 6.6 will be the cornerstone of the entire chapter or the entire module. Dito natin i-derive yung ito yung gagamitin natin sa pag-derive nung differentiation formulas natin. So usually nag-start lagi tayo sa expansion na to. Moreover, Taylor's theorem also allows us to truncate the summation into a finite one, tapos binibigay niya rin yung error term. So kung gusto mo lang gamitin, say hanggang order n na term, so pwede mong isulat yung first few terms that you want to use. And then if you say, titigil na ako dito, then the error term, when you chop it off at that particular point, will become the next term, the supposedly next term, but evaluated at a number psi in the neighborhood capital X. So kung ita-truncate ko yung Taylor series expansion hanggang dun lang sa may power n, okay? Yung error term sa kanya would be the power n plus 1 term. Kaya lang yung x, papalitan ko na by an arbitrary number c on the closed interval on the neighborhood of capital X. Sorry, on the neighborhood capital X. All right, so tandaan nyo itong 6.6 and 6.7 kasi ito yung magiging foundation ng mga susunod na mangyayari. Okay? And this is nothing new. This is already you have already encountered it in Math 36 or 38. Hindi ko maalala kung saan nyo siya dapat nakita. Pero ang pinagkaibahan lang siguro possibly rito ay nagkaroon ng plus H. Sa Math 36 wala yung plus H. So yeah. Okay. Now, the parameter H plays an important role sa formula na to. You can think of the expansion of f of x plus h to be a polynomial in H. Okay. Tapos kung ano yung power ni H, kung ano yung derivative, which usually comes with the same power of H, is called the order of the truncation. So this guy, equation 6.7, is the order n truncation of the Taylor series. Kasi tinigil natin yung summation dun sa nth derivative ni f, right? And then we just replace the infinitely many terms after it by the error term. Okay, so ito yung expansion of order n. Okay. Now, ang idea natin sa i-develop nating numerical differentiation techniques, gusto natin na gumamit ng isang gumamit lang ng finite number of terms para makalculate yung derivative at a particular number x. Again, we want to use this expansion to get a formula for f prime evaluated at x. And then we have two options here. Number one, we can declare what would be the number of points used. Ilang points yung gagamitin ko para dun sa derivative formula. So of course, you want to use function value f of x. Tapos posible ka pang may gustong idagdag. Pwede mo rin gamitin yung f of x plus h. Pwede mo rin gamitin si f of x plus 2h. Pwede mo rin gamitin si f of x minus 2h and f of x minus h. So ikaw yung magde-decide ilang points yung gusto kong gamitin. Just make sure that you have access to this data. So ang idea rito, yung numerical differentiation formula that we will develop, dapat nakadepende lang siya sa mga function values. Function values ng ilang mga points na malapit kay x. So rito, halimbawa, nag-decide ako, 5 points yung gagamitin ko. Yung 5 points na pinakamalapit kay x. So, syempre, sasama ko na si x, yung sarili niya, plus function value sa 4 pang mga points that is centered at x, or some points that are near the value of x. And then the second option that I can preset would be anong order yung gagamitin ko. You will see later, probably in module 7, ano yung implication ng order. Okay? For now, you can think of the order as ilang terms dun sa Taylor series expansion yung kailangan kong i-keep dun sa differentiation para ma-achieve yung order na yon. And that order usually depends on h. Okay? And probably for that, sabihin ko na ba siya? Okay. Siguro later ko na sabihin kung ano yung order. I'll mention something about the order later. But let's see. Let's try to see this method, or the method I'm describing in action. In particular, I want to derive the same formula na present natin kanina using x sub 0 and x sub 1. Yung gumamit ako ng interpolation for 2 consecutive points. Okay? So kung matatandaan nyo, ang ginamit dun sa formula na yon ay ang approximate natin para kay f prime at x sub 0 ay yung slope. F of x sub, what was that? F of x sub 1 minus f of x sub 0 over x sub 1 minus x sub 0. And then the error term is h squared. What's that, h squared? Second derivative, evaluated at psi all over 2 times x0 minus x1. Okay. Pero yung x0 minus x1, pwede ko siyang tingnan as the increment h. So yun yung difference between 2 consecutive function values. Okay. Now, kung gusto ko itong i-derive, kung makikita nyo, gumamit tayo ng 2 points. The function values at x1 and at x sub 0. So ganun yung titingnan ko. Gagamitin ko si x0 at saka yung susunod na point sa kanya. I can assume that x sub 1 is equal to x sub 0 plus h. Alright? Kasi meron lang ako increment h na ginagamit. And let's try to derive this using Taylor's formula. Okay? And then kung mapapansin nyo, yung formula ay yung formula ay order 2. Kasi yung error term niya ay second derivative. Okay? Hindi pala. Order 0. Order 2 yung derivative niya, pero yung error niya nakadepende kay h. I mean, is a multiple of the increment h. Kaya itong formula na to ang tawag ay order 1. Kasi ang formula na to, ang error term niya ay isang multiple lamang ni h to the first power. Kasi nga pala si f double prime at psi ay constant. Constant siya pero hindi natin alam kung ano yung value niya kasi si f double prime ine-evaluate natin sa isang unknown number c on the interval x0 to x1. So essentially, we can abbreviate this error by saying that this is just a big O of h. Kung natatandaan niyo yung big O notation, right? In this case, we're talking about the big O notation in an infinitesimal sense. Ibig sabihin, yung big O of h, ibig sabihin niya, yung error term ay lumalapit kay 0 at the same speed at which h approach 0. So, ibig sabihin, linear yung pagbaba nito papunta kay 0. So, if h decreases, then it will decrease by a constant factor f double prime of psi all over 2. Or kung ayaw nyo nang balikan yung interpretation na yon ng big O notation, pwede nyo tingnan, ito ay constant. Remember, sa big O, dinadrop lang natin yung mga constant multipliers. So we can't forget about it. Then we can say na, okay, bumababa lang yung error, papunta kay 0 in the same speed or the same pace as how h will approach 0. Okay? Kaya ito ang tawag sa kanya order 1. Kasi yung error niya ay order big O of h to the first power. Okay? So, paano ko ito madiderive? Alam ko, gagamit ako ng 2 points. Tapos, kailangan order 1 yung makuha kong formula. So, kung gagamit ako ng 2 points, kailangan kong gamitin si f of x saka si f of x plus h. Balik ka kay Taylor formula. So, gagamitin si f of x plus h. Luckily, kay Taylor formula, sa expansion ni f of x plus h, kasama na si f of x. So I don't need any other formula but I'll stick with 6.6. Tapos gusto natin ay formula para kay f prime. And look at f prime over here. Ayun si f prime. Meron siyang multiplier na h. So ibig sabihin, later when I derive everything, mag-divide ako by h both sides para makuha si f prime. Right? Kasi again, ang goal ko makahanap ng formula para kay f prime. So I'll manipulate equation 6.6 para ma-compute si f prime. But since f prime has a multiplier h to it, kung ano man yung ma-compute ko or paano ko man siya i-manipulate, kailangan later mag-divide ako ng h both sides para ma-isolate si f prime. So pag nag-divide ako ng h both sides, kailangan kong hanapin, kailangan ko ititigil yung summation. Saan ko siya itra-truncate? Remember, ang goal natin is to get a formula of order 1. Kailangan yung error term ay magkaroon ng h to the 1 na multiplier. And if you look at here, pwede na akong tumigil sa f double prime. Pwedeng dito ko itigil yung expansion kasi pag nag-divide ako both sides mamaya by h, which I needed to do because again, meron akong h times f prime. I am computing for f prime, so I'll be obliged to divide both sides by h. Pag nag-divide ako both sides by h, so lahat ng mga terms dito madi-divide then by h. So I'll have h squared over h, that will give us h, which is what we want to be retained dun sa error term. So ibig sabihin, I won't bother looking at the higher ordered terms. Pwede pa lang dito ko na i-truncate yung summation. Or ito yung itira ko as my intended error term. Kasi nga, meron man siyang h squared at this particular moment, pero pag dinivide ko later both sides by h, matitira na lang ay h times f double prime all over 2 factorial. Okay? So that will give us a formula of order 1. And that is what was done here in this quick example here. Kinuha ko yung expansion, okay, ni f of x plus 1. Kaya lang, alam ko na pwede ko nang itigil to after the linear term h times f prime. Kasi nga gusto ko matira talaga si f prime. Tapos, ititigil ko yung summation hanggang makuha ko yung desired order. Para makuha si order 1, nakita natin na dapat kasama si h squared times f double prime of x over 2 factorial. But I am reserving that to be the error term. Okay? Dahil error term siya, from the Taylor's theorem or the second part of Taylor's theorem, pwede ko siyang palitan ng number c over the interval x to x plus h. So you can say here c is a number between x and x plus h. Yun yung nasa error term. And again, this is just a linear equation for f prime. So pwede kong ilipat ito papunta sa kaliwa, tas ito lipat ko rin papunta sa kaliwa, tas I'll flip the equation. I'll get this guy, h of f prime equals that sum there. And then, ito na yung sinasabi ko. Ito yung in-anticipate natin kanina na kailangan ko mag-divide by h to get the final line or the final expression for f prime. And doing so, we'll get this guy divided by h, okay, plus this guy divided by h, actually, that pala to ay minus. Tama nga ba? Minus h times f double prime of c all over 2. And essentially, that's what we got, right, from this formula. Actually, negative h pala to. Kasi ang h natin, sinabi natin na x1 minus x sub 0. So remember, yung nasa error term kanina ay x0 minus x1. So that's why we have negative h in here. Okay? So that's how we got this formula. And if you take x plus h to be x1 and x to be x sub 0, then we retrieve the formula that we got earlier. Okay? So ito yung isang way paano na-derive yung kanina. And just so happened that using 2 points interpolation to get the approximate derivative coincided with a 2-point finite difference formula of order 1. So yun yung tawag natin dito. 2 points kasi gumamit tayo ng x plus h at saka x in our formula. And it's order 1 because the error is a factor of the increment h. Right? And again, it seems that theoretically a nice way on how to get this formula to be better and better approximate for f prime is to just really decrease the value of h, right? Kasi mas maliit si h, mas maliit yung error term, that means the better the approximation is. However, magkakaroon tayo ng problema. Look at the formula 6.8. Pagka si h ay malapit kay 0, yung divisor nito magiging malapit kay 0. And that can spell some problems for us when we do a machine implementation of this. And we will look at that probably in module 8 or module 7. Paano natin ma-reconcile yung theoretical error at saka yung machine error to get the optimum value for h. But for now, we will focus on deriving finite difference formulas. Okay? All right, so any questions, guys, so far before I proceed to a more complicated example? Questions? Wala kayong tanong? Okay. Or hihiya pa rin kayo magtanong? Okay, so if not, let's look at another example. So let's look at example 6.1. In this example, we are told to obtain a 3-point forward formula. So, kailangan natin ng 3 points. Tapos forward yung sinabi. So we are deriving a formula for f prime. Okay, ito yung hinahanapin natin ng formula. Tapos sabi ay 3-point forward. So that means we will need 3 points starting from x, but we will go forward. So we'll start at using function value f of x, then f of x plus h, and then we'll use f of x plus 2h to complete the 3 points that we are required to use in this formula. Okay? Ito yung forward formula na tinatawag. So mula kay x, magdagdag ng multiples ni h hanggang makabuo tayo ng 3 points. Okay? Tapos order 2. Order 2 daw, so kailangan yung formula nating ma-derive ay may factor or may multiple ni h squared yung error term. Okay? So the error term should be a big O of h squared. Okay? Now, kailangan kong gamitin si f of x plus 2h, at saka si f of x plus h. Now, we will look at the individual expansions for these two guys. Wala tayong problema kay f of x kasi yung f of x nasa formula na siya ni f of x plus h at saka ni f of x plus 2h. So we need to look at the expansions of f of x plus h and f of x plus 2h. All right? Now, balikan natin yung expansion formula mula sa equation 6.6. Okay? So ito yung para kay f of x plus h. Para mapalitan to para mahanap yung expansion para kay f of x plus 2h, lahat lamang ng h's na makikita natin sa equation 6.6, papalitan ko lang by 2h. So essentially, f of x plus 2h will then become f of x plus the second term. H will be replaced by 2h. So we're going to have 2h times f prime of x plus, in the third term, h squared will be replaced by 2h. H in h squared will be replaced by 2h. So we will have 2h quantity squared f double prime of x all over 2 factorial and so on. So lahat lamang ng h's, papalitan nyo ng 2h. Okay? And then we'll need to consider kailan ako titigil sa expansion. Okay? Now, again, remember, we're looking for a formula for f prime. Pero yung f prime, mapa kay f of x plus h man, o kay f of x plus 2h, yung f prime, laging may kadikit na, yung f prime, laging may kadikit na h. So again, we expect that when we do the final formula, magdi-divide ako both sides by a factor of h para mawala yung h na katabi nila f prime. So magdi-divide ako by a factor of h. Ano nga yung order na kailangan natin? Order 2? Yeah, kailangan ko ng order 2. So ibig sabihin, magdi-divide ako by h. Kaya lang gusto kong may matira na big O of h squared dun sa error term. So ibig sabihin, dapat titigil ako hanggang dun sa may h cubed. Right? So that means I will use these terms in the expansion of f of x plus 2h, at saka dadagdagan ko pa ito ng isa, yung kay f of x plus 2h, dadagdagan ko siya ng 2h cubed f triple prime of x all over 2h, kasi nga dapat yung final answer natin ay big O of h squared. Okay? Kaya lang, we anticipate dividing both sides of the equation that we'll get by h. So ibig sabihin, dapat may h cubed yung summation natin. So kailangan isama ko to sa expansion. Kailangan isama ko rin to sa expansion, right? But I will replace all x's by c's, by the arbitrary number c's, because we are reserving these terms to be part of the error term. Okay? And yun yung ginawa dito sa example 6.1. Kinuha yung expansion ni f of x, tumigil siya dun sa h cubed. Yung f of x plus 2h, tumigil din siya dun sa may h cubed. And then now, ano yung gusto nating matira? Sinusolve ko si f prime. So pwedeng matira ito dun sa final equation, or actually gusto nating matira ito para meron tayong f prime both sides. Kaya ito, gusto ko rin itong matira kasi dito manggagaling yung error term. Right? Ito yung i-reserve natin sa error term. Ang problema natin na ito, we don't want this to persist in the formula, because that will require us to use the value of f double prime. Problema, hindi nga natin alam si f prime, so chances are we also don't know f double prime, or the value of f double prime at the number x. So in the formula that we will be deriving, we don't want these terms to linger on, kasi nga gusto lang natin gamitin si f of x plus h, at saka si f of x plus 2h. So we need to find a way so that these terms will just vanish in the expansion. Okay? Paano natin siya mapapawala? Paano sila mawawala dun sa expansion? Ang clue I will take a linear combination of these two equations or the sides of these two equations. So ano kaya yung pwede kong gawin para mawala ito? Any guess? Any idea? Ano ko siya mapapawala? I hope clear kung bakit siya kailangan mawala, right? Kasi hindi nga natin alam si f double prime. At saka ang usapan, 3 points lang yung gagamitin natin. F of x plus h, and f of x plus 2h. So these two terms somehow should go away. And how can I make that, or these two terms go away? Paano ko sila ma-eliminate? Yun na yung clue. Paano sila ma-eliminate? Guys, sagot kayo. Bonus yan sa problem set. Bala kayo. Pag hinirapan ko yung problem set, manghina yan kayo sa bonus points.
Sir, multiply lang 4 times f of x plus h.
Multiply yan yung f of x plus h by what?
By 4. Para po ma-eliminate yung choices of equation.
Alright, thank you, Chazel. Nakalimutan ko pala magtanong ng iba kasi nakasagot na si Chazel. Ang daya ni Chazel. Though, counted lang as once yung Chazel. So next time, yung iba naman yung sasagot. Okay, so yeah, tama si Chazel. Mag-multiply tayo ng 4 dun sa first equation. And then we subtract the first equation from the second or the other way around. So yun yung ginawa dito sa next line. Para nag-eliminate ako, in-eliminate ko yung term with f double prime. Ito ay may 4h squared over 2. Ito ay may h squared over 2. So all I need is to multiply both sides of the first equation by 4 and then subtract this guy from the second equation. And that's what was done here. I computed for f of x plus 2h minus 4 times f of x plus h. Algebraic manipulation, you'll get this. And then, gusto kong ma-isolate yung may f prime sa isang side. So I'll transfer this guy to the other and everything here to the right side para isolated si 2h f prime sa isang side. Tapos, kung makikita nyo dito, hindi na ako concerned dun sa nangyayari dun sa dulo. Concerned lang ako hanggang dun sa kay h cubed. Kasi nga gusto ko lang matira ay may h squared. And I am anticipating dividing both sides by h or by a factor of h. Kaya eto na lang talaga yung tinitira natin. And you see the nice thing about what Chazel suggested, wala na talaga dito yung may f double prime. We don't want that to linger on in our equation. Okay? So at this point, we can just divide both sides by 2h to get the formula for f prime. So we'll get f prime is equal to this guy plus 2h squared over 3 times f triple prime of x plus some other terms, which we don't care about because starting here until here, they will just be big O of h squared. Kasi nga, kung mapapansin nyo yung nandito, yung susunod na term ay may h cubed times something plus h to the 4th times something. Pero remember sa big O notation, we forget about those lower order terms or those insignificant terms. Habang lumiliit na lumiliit si h, yung contribution ni h cubed ay insignificant na compared dun sa contribution ni h squared. Habang si h ay lumiliit ng lumiliit, yung contribution ni h to the 4th ay insignificant na compared dun sa contribution ni h squared. So starting from here hanggang sa dulo ng summation, kahit infinite man yan, yung pinakamay malaking contribution. And in fact, the only term that has a significant contribution is this guy. Kaya pwede nating sabihin, pwede ko na palitan itong lahat ng to by big O of h squared. Okay? Kasi nga yung f triple prime of x, that can be bounded by a value of x from x plus 2h. Divide mo by 3, times mo ng 2. Insignificant naman lahat ng constant factors of big O. So essentially, you can simplify everything and say whatever is remaining is a big O of h squared. And hence, we can say that a 3-point forward formula of order 2 is this guy. Tapos pwede natin itong ipampalit dun sa pagko-compute ng derivative. And the error term is whatever was truncated here. Ito yung error term. but we will replace x by c. Okay? So, kinopya ko lang tong error term, pinalitan ko si x by an arbitrary by some number c. Kaya lang, unfortunately, hindi natin alam kung ano yung value ni c. Alam ko lang si c ay isang number from x plus 2h. Okay? So I hope everything is making sense. Okay. Pwede ba mangutang ako ng 5 more minutes para lang matapos ko yung mga examples. Then para next time, mag-Excel tayo. Doon na tayo mag-start sa paggamit ng Excel. Okay, so if that is fine, I'll skip example 6.2. You can redo it. The process is similar, except that dito ang hiningi ay 3-point backward formula. So sa backward formula, 3 points. So kailangan mag-start ka kay f of x. Kaya lang kailangan mong backward daw, so pabalik. So ang kailangan mong susunod na point ay x minus h. Correct? And then dahil 3 points yung kailangan, f of x minus 2h. Ito yung tatlong points na gagamitin natin. Tapos, order 2 ulit. Ibig sabihin, kailangan ko yung expansion ng f of x minus h. Paano natin siya makukuha? Babalik tayo dun sa theorem 6.6. Hindi ko na-resist na wag i-discuss yung example 6.2. So, sige, hanggang 6.2 ako ngayon. So, remember, ang f of x plus h ay f of x plus h f of f prime of x plus h squared f double prime of x all over 2 factorial and so on. Okay. So para makuha si f of x minus h, kung mapapansin nyo, pinagkaiba lang nila, we have negative h instead of h. So dun sa expansion, mula dun sa equation 6.6 yata yun, sa Taylor's theorem, lahat lang ng h, palitan nyo lang ng negative h. So here we'll have f of x minus h f prime of x. And then h here will be replaced by negative h. So we're going to have negative h quantity squared. So we'll have positive h squared f double prime of x all over 2 factorial. And then we'll have minus h cubed f triple prime of x over 3 factorial and so on. Then the same thing will be done for f of x minus 2h. We just replace all h's by negative 2h. Just be careful with the signs. So, kailangan extra careful kayo doon. And then, anong kailangan natin? Kailangan natin ng order 2 formula. Dahil order 2 yung formula, kailangan nating malaman kailan ako titigil. Pero again, yung f prime, lagi siyang accompanied by h. So therefore, later in our manipulations, we will have a factor of h times f prime. And then to get the formula for f prime, we need to divide both sides by a factor of h. Tapos gusto ko order h squared, so dapat may matirang h squared after division by h. To have a quotient which have an h squared, kailangan i-consider ko hanggang kay h cubed, right? Kasi h cubed yan, divide ko both sides by h, may matitira ko na h squared. And that's what was done here. Kinonsider ko lang hanggang dun sa may h cubed. Because again, I know I'm gonna divide both sides by a factor of h later. Okay? So kaya hanggang ganon yung expansion. And again, you can analyze this, okay? We're good with f of x. Gagamitan talaga na pwede natin siyang gamitin or i-retain dun sa formula kasi allowed siyang gamitin by our plan. And then yung f prime, talagang dapat matira siya dyan kasi nagsasolve tayo ng formula para kay f prime. These terms cannot linger on until our final answer kasi involves the f double prime and possibly we don't have, or more likely we don't have any data for f double prime. So these two terms must go. These terms with h cubed should be retained kasi sila yung mag-maintain ng error term. Okay? So kaya, ang problema lang natin dito, gusto kong mawala itong factors ni f double prime. And as what we have done earlier, we can multiply both sides of this equation by what? By 4 again, times 4, everything here times 4, and then we can do the same thing we did earlier, okay? And we'll end up with this formula, for this backward formula. And then the error term will be similar to what we got using the forward formula. But this time, the number C is some number between x minus 2h and x. All right. So I hope this gives you a nice introduction on how to derive this formula. Hopefully, also it gave you an idea how to proceed if we will use more points and if we want higher degree. And that's what we'll do on Thursday. So we'll start with example 6.3 and hopefully be able to reconstruct the table in section 6. In example 6.4. Okay. Now, any questions? Okay, walang tanong. Hopefully, tahimik kayo kasi madali lang yung topic. All right. So I hope that's the reason why you are quiet. But if there are no questions, then can I request those who recited verbally to put a comment dun sa chat? Paki-comment na lang nung nicknames nyo para ma-take note ko na nag-recite kayo for today. This will give you small bonus, hindi naman kalakihan, pero konting points sa problem sets. And hopefully, more and more of you will be willing to recite. Hindi naman kailangan tama yung sagot. Sabihin nyo lang yung idea nyo, and that will give you small bonuses to the problem sets, okay? All right, so I think, yeah, that's it for today. So thank you guys for joining. Good luck sa problem set. You can go online in Canvas tomorrow, download it starting 8 a.m. And then the deadline is on November 1st. And yeah, and enjoy the rest of your day. And let's see each other again on Thursday. Bye, everyone.
Thank you po,